The story of our quest to understand the universe began long ago in the minds of ancient philosophers who dared to ask the biggest questions. Imagine yourself in ancient Greece, where the seeds of science were first planted, an era when the world was still a mysterious place, full of unexplained phenomena. Around 2,500 years ago, thinkers like Socrates, Plato, and Aristotle roamed the streets of Athens, engaging in deep discussions about knowledge, reality, in the natural world. These early philosophers were the first to step beyond the myths and legends that dominated human thought. They began to seek rational explanations for the world around them, laying the foundations for what would one day become the scientific method. They asked questions that no one had dared to ask before. What is the nature of reality? How can we truly know anything? What is the world made of? Their ideas would resonate through the ages, guiding humanity's understanding of the universe and setting the stage for the scientific revolutions that would follow. From the abstract concepts of Plato's forms to Aristotle's meticulous observations of nature, these ancient minds started a journey that has led us to the heights of modern science, where we continue to seek answers to the same fundamental questions that puzzled them. But how did these early ideas evolve into the scientific theories that explain our world today? How did the philosophical inquiries of ancient Greece give birth to a method of inquiry that would uncover the secrets of atoms, the laws of physics, and the origins of life itself? This is the story of philosophy and science, a story that begins in ancient Greece and continues to shape our understanding of the universe. Ancient Greek philosophy is the bedrock of Western thought, laying the foundation for how we understand knowledge, reality, and the natural world. The most prominent figures in this intellectual tradition, Socrates, Plato, and Aristotle, each contributed profoundly to the philosophical landscape, shaping not only their own eras, but also the development of modern science. Socrates, often regarded as the father of Western philosophy, did not leave behind written works, but his ideas are preserved through the dialogues of his student Plato. Socrates emphasized the importance of questioning as a method of attaining knowledge, a technique known as the Socratic method. He believed that through dialogue and persistent questioning, one could uncover underlying truths about the world and the self. For Socrates, knowledge was intimately connected to virtue. To know the good was to do the good. His philosophical approach was less about providing answers and more about stimulating critical thinking, urging people to examine their own beliefs and the world around them. Plato, a student of Socrates, expanded on his teacher's ideas and introduced his own theories on knowledge and reality. Central to Plato's philosophy is the theory of forms or ideas. He posited that the physical world is not the true reality, but merely a shadow of the real, unchanging world of forms. According to Plato, everything in the physical world is an imperfect representation of its perfect form. For instance, a circle drawn in the sand is just an approximation of the perfect form of a circle that exists in a non-physical realm. Plato also believed that true knowledge could only be attained through intellectual reasoning, as the senses are unreliable and can only offer opinions, not truth. His famous allegory of the cave illustrates this idea, where prisoners in a cave mistake shadows on the wall for reality, unaware of the true world outside. Plato's view on the natural world was that it was in a constant state of flux, and thus only the forms represented the eternal and immutable truth. Aristotle, a student of Plato, took a different approach to philosophy, emphasizing empirical observation and experience as the basis for knowledge. Unlike Plato, Aristotle believed that the physical world is the real world, and that by studying it, one could gain true knowledge. He rejected Plato's theory of forms, arguing instead that forms and substances are inseparable, and that the essence of a thing is found within its physical manifestation. Aristotle's contributions to the natural sciences were groundbreaking. He categorized the natural world into different groups and species, laying the groundwork for what would become biology. His approach to understanding the universe was systematic and logical. He sought to explain the nature of things through cause and effect, a method that would influence the development of the scientific method centuries later. Aristotle also introduced the concept of the four causes: material, formal, efficient, and final, as a framework for understanding why things exist and happen. This method of inquiry allowed for a more structured investigation into the natural world, where one could analyze not just what things are made of, but also their purpose and the processes that bring them into being. Socrates, Plato, and Aristotle each approached the understanding of the universe in ways that laid the foundation for future philosophical and scientific inquiry. Socrates emphasized ethical reasoning and the importance of self-knowledge. Plato introduced a metaphysical framework that sought to explain the relationship between the material and immaterial worlds, and Aristotle grounded knowledge in empirical observation and logical analysis. Together, their ideas formed a comprehensive approach to understanding the universe, one that combined abstract reasoning with empirical study, and one that continues to influence how we seek knowledge today. Whether through Socratic questioning, Platonic ideals, or Aristotelian logic, the legacy of these philosophers endures, guiding our quest to unravel the mysteries of existence. The transition from philosophical speculation to scientific inquiry is one of the most significant developments in human history. Ancient Greek philosophy played a crucial role in this shift, laying the groundwork for what would become the scientific method. Through the work of philosophers and thinkers like Archimedes, the Greeks moved from abstract reasoning to systematic observation and experimentation, establishing principles that still underpin modern science. Greek philosophy introduced critical thinking, logic, and the pursuit of knowledge as fundamental tools for understanding the world. Philosophers like Socrates, Plato, and Aristotle emphasized the importance of questioning, reasoning, and empirical observation. Aristotle, in particular, made significant strides in formalizing a method of inquiry that closely resembles the scientific method used today. Aristotle's approach involved careful observation, categorization, and analysis of the natural world. He believed that knowledge could be derived from direct experience and that systematic observation could lead to general principles or laws. This empirical approach contrasted with Plato's emphasis on abstract reasoning and the world of forms, marking a pivotal moment in the development of scientific thinking. Aristotle also introduced the concept of causality, which became a fundamental principle in science. He proposed that to understand any phenomenon, one must identify its causes: material, formal, efficient, and final. This method of inquiry laid the foundation for scientific investigation, where understanding the causes of events is crucial to explaining the natural world. One of the most important figures in early scientific thinking was Archimedes, a Greek mathematician, physicist, and engineer. Archimedes' work exemplifies the application of philosophical reasoning to practical problems, bridging the gap between theory and experimentation. Archimedes made significant contributions to mathematics, particularly in geometry, where he developed methods for calculating areas and volumes that anticipated integral calculus. However, his contributions to physics are perhaps even more groundbreaking. He formulated the principle of buoyancy, known as Archimedes' principle, which explains why objects float or sink in a fluid. This principle was not just a theoretical idea, but was derived from careful observation and experimentation. Archimedes also pioneered the use of mathematical reasoning to solve physical problems. His work on levers, pulleys, and other simple machines demonstrated how mathematical principles could be applied to understand the mechanics of the natural world. His famous exclamation, "Eureka," supposedly came when he discovered how to measure the volume of an irregular object by submerging it in water, a moment that highlights the importance of empirical observation in scientific discovery. The shift from Greek philosophy to scientific thinking involved applying abstract ideas to the real world through systematic observation and experimentation. The Greek philosophers' emphasis on logic and reason provided a framework for understanding the natural world, but it was figures like Archimedes who demonstrated how these principles could be applied practically. The process of moving from philosophical inquiry to scientific method involved a few key steps. First, the Greeks recognized the importance of observation as a source of knowledge, which Aristotle formalized through his empirical approach. Second, they began to apply mathematical reasoning to these observations, using logic to derive general principles from specific cases. Finally, thinkers like Archimedes showed that experimentation, testing hypotheses through controlled conditions, was essential to confirming or refuting these principles. This progression laid the foundation for the scientific method as we know it today. Observation, hypothesis, experimentation, and conclusion. The Greeks' commitment to reason, combined with their willingness to test ideas against the physical world, set the stage for the development of science as a systematic and reliable way of understanding the universe. Ancient Greek philosophy not only shaped the intellectual landscape of its time, but also laid the foundation for many modern scientific theories. The ideas of Greek philosophers have endured through the centuries, influencing how we understand the natural world, matter, and the cosmos. In this section, we'll explore how key concepts from Greek philosophy, such as atomism and classification, have evolved into some of the fundamental theories in modern science. Atomism, from Democritus to modern atomic theory. One of the most significant contributions of Greek philosophy to modern science is the concept of atomism, which originated with the philosopher Democritus in the 5th century BCE. Democritus proposed that all matter is composed of tiny, indivisible particles called atoms, which move through the void. He believed that these atoms were eternal, unchanging, and formed the basis of all physical reality. While Democritus's ideas were largely speculative and lacked empirical evidence, they introduced a crucial concept that would later become a cornerstone of modern chemistry and physics. Fast forward to the 19th and 20th centuries, and the idea of the atom was revived and refined by scientists like John Dalton, J.J. Thomson, and Ernest Rutherford. Through a series of experiments, they demonstrated that atoms do indeed exist and are made up of smaller subatomic particles like electrons, protons, and neutrons. Modern atomic theory, which includes quantum mechanics and the standard model of particle physics, can trace its roots back to the atomistic philosophy of Democritus. The idea that matter is composed of fundamental building blocks remains a central tenet of science today. Another area where Greek philosophy has had a lasting impact is in the field of biology, particularly in the classification of living organisms. Aristotle, often referred to as the father of biology, was one of the first thinkers to systematically study and classify the natural world. He observed and categorized animals and plants, creating a hierarchical system of classification based on shared characteristics. Aristotle's great chain of being organized life forms from the simplest to the most complex, placing humans at the top. Aristotle's approach to classification laid the groundwork for taxonomy, the science of naming and classifying organisms. In the 18th century, Carl Linnaeus built on Aristotle's ideas to develop the binomial nomenclature system, which is still in use today. Linnaeus's system of classification, which groups organisms into a hierarchical structure of kingdoms, classes, orders, families, genera, and species, reflects Aristotle's influence in organizing the natural world based on observable traits. Furthermore, Aristotle's emphasis on empirical observation as a means of understanding the natural world directly influenced the development of evolutionary theory. Charles Darwin, in his work on natural selection, relied on the careful observation of species and their adaptations, an approach that echoes Aristotle's methodical study of living organisms. Greek philosophy also played a significant role in shaping our understanding of the cosmos. The early Greek philosopher Pythagoras suggested that the Earth was spherical, and later thinkers like Aristarchus of Samos proposed that the Earth revolved around the Sun, an early form of the heliocentric model. However, these ideas were overshadowed by Aristotle and Ptolemy, who advocated for a geocentric model, where the Earth was the center of the universe. It wasn't until the Renaissance that the heliocentric model was revived by Copernicus, who cited ancient Greek ideas as part of his inspiration. Copernicus's work laid the foundation for modern astronomy, leading to further developments by Kepler, Galileo, and Newton, who provided the mathematical and observational evidence needed to establish the heliocentric model as the correct representation of our solar system. The shift from a geocentric to a heliocentric worldview was a pivotal moment in the history of science, rooted in the speculative philosophy of the ancient Greeks. The philosophical foundation of science. The connection between philosophy and science is not just historical, it's ongoing. Philosophy provides the conceptual framework within which scientific inquiry operates. The questions, methods, and even the very nature of what constitutes knowledge in science have deep philosophical roots. In this section, we'll explore how philosophical inquiry continues to influence scientific thought and how the two disciplines remain intertwined. At its core, science seeks to understand the world through observation, experimentation, and reasoning. However, the fundamental questions that guide this process, such as what can we know, how do we know it, and what counts as evidence, are inherently philosophical. These questions are explored in the branch of philosophy known as epistemology, which deals with the nature and scope of knowledge. The scientific method itself, which involves formulating hypotheses, conducting experiments, and drawing conclusions, is grounded in philosophical principles. The idea of falsifiability, introduced by philosopher Karl Popper, is a key concept in science. It suggests that for a hypothesis to be scientific, it must be testable and capable of being proven false. This idea has shaped modern scientific practice, ensuring that scientific theories remain subject to scrutiny and revision. Philosophy also plays a crucial role in defining the limits of scientific inquiry. The debate between empiricism and rationalism, whether knowledge comes primarily from sensory experience or from intellectual reasoning, continues to influence how scientists approach their work. While empiricists emphasize the importance of observation and experiment, rationalists focus on the role of logic and mathematics in uncovering truths about the universe. Modern science integrates both approaches, reflecting a philosophical balance between data-driven research and theoretical modeling. Beyond methodology, philosophy is essential in interpreting scientific theories and their implications. For instance, the interpretation of quantum mechanics, a field filled with counterintuitive concepts like superposition and entanglement, remains a hotbed of philosophical debate. Different interpretations, such as the Copenhagen interpretation and the many worlds hypothesis, reflect underlying philosophical positions about the nature of reality and causality. Similarly, the ethical implications of scientific discoveries are deeply philosophical. Questions about the moral responsibility of scientists, the ethics of genetic engineering, or the implications of artificial intelligence all require philosophical analysis. This is where philosophy intersects with the social impact of science, guiding decisions about how scientific knowledge should be applied. Moreover, philosophy encourages scientists to think critically about the assumptions underlying their theories. For example, the principle of causality, that every effect has a cause, is a philosophical idea that underpins much of scientific thinking. However, in certain areas of physics, such as quantum mechanics, this principle is challenged, leading to new philosophical questions about the nature of cause and effect. The relationship between philosophy and science is not static. It is a dynamic dialogue that continues to evolve. As science advances, it often raises new philosophical questions. For example, the discovery of the expanding universe led to philosophical inquiries about the nature of time and space. Similarly, developments in neuroscience challenge our understanding of consciousness and free will, prompting philosophical debates about the mind-body problem. Conversely, philosophical ideas can lead to new scientific inquiries. The concept of symmetry, rooted in philosophical thought, has become a central principle in physics, guiding the development of theories like relativity and quantum field theory. Philosophy also provides the tools to critically evaluate scientific paradigms and explore alternatives when existing theories are inadequate, as seen in the shift from Newtonian mechanics to Einstein's theory of relativity. Philosophy and science are deeply interconnected, with philosophy providing the foundation for scientific inquiry and offering the tools to interpret and critically assess scientific theories. This ongoing relationship ensures that science remains a thoughtful and reflective endeavor, grounded in a deep understanding of knowledge, ethics, and reality. As science continues to push the boundaries of what we know, philosophy will remain an essential partner in exploring the implications of these discoveries and in guiding the future direction of scientific inquiry.